Alright, so we're going to make a video here showing just very briefly how to apply these equations. So we have this vertical displacement equation, we have this vertical velocity equation. How do we use them? How do we write them? And so I've given you a problem here. It says that a baseball is thrown at 7 meters per second at an angle of 65 degrees. Write a vertical velocity and a vertical displacement equation. Find the velocity at 0.5 seconds and the height at 0.4 seconds. So you see that there's quite a bit to do, but let's just break it down into each piece. The first thing I'm really asked to do is to write a vertical velocity equation. Alright, well, let's start there. The vertical velocity equation, as you learned in a previous video, looks like this. Vy equals Vyi plus gt. Again, you just should have that in your notes. You can use your notes to look it up. You don't have to memorize it. G is going to be negative 9.8, of course, but really important. This part right here, we must actually figure out what Vy is, because this is not the velocity. Some of you are going to want to put in 7. It's not just the velocity, it's more specific. It's the vertical component of velocity. That's why I put the y there. The Vy indicates the vertical component, because this is a vertical velocity equation. I don't care about what it's doing side to side. And the 7 is both up and down and side to side, right? So we need to actually find that component. And of course you probably know how to find it. I'm just going to draw a sketch real quick though, just so you see it. So we have 7 meters per second, and this is at 65 degrees. Now, we are only interested in this vector right here, this component, this piece. How much is it actually going up and down? We know 7 is like the hypotenuse, and there would be another vector too down here at the bottom, the horizontal component. We don't care about it for this problem. Eventually we will care about the horizontal component. But here I only care about the vertical component. This is Vyi. This would be like Vxi if it mattered, but Vyi is just that piece. So of course, to calculate that, I have to use sine, and you have that equation. You can go back and think, okay, we have a hypotenuse and we have the opposite side, and so you have opposite hypotenuse, so or sine. But the equation is going to look like this. Vyi is going to be equal to v times the sine of the angle theta. So this is going to be now this is my initial, right, because this represents my hypotenuse. So 7 times the sine of 65 degrees. And so I'll just punch that in my calculator. Again, make sure you're in the correct mode. It must be in degrees. 7 times sine of 65 gives me 6.34. We'll say 6.34. So we get 6.34. Actually, let's just do 6.3. Only because a lot of times on the Google form sheets that I'm asking you to do, I ask you to round to 1. So I'll round to 1 as well. 6.3 meters per second. Great. So that's my vertical component. Let's go back over here and finish writing this equation. Once you have the vertical component, it's really important to keep this around, because we're going to use this twice. But yeah, this equation is going to be Vy is going to be equal to Vyi, which is 6.3. That's what we just discovered over here. 6.3 plus G is negative 9.8 times T. So if you want to make it look a little nicer, you can just put 6.3 minus 9.8t. Again, this is an equation, this is a function that describes velocity as a function of time. You plug in a time, you're going to get a velocity back out. And so this describes the velocity of that object at any point in time. Alright, I'm going to, well, I guess I can just keep that here for now. I'll move this all over a little bit, or I'll twist it around. One of the two though. Alright, so now the second part, write a vertical displacement equation. Now vertical displacement is a little bit longer, a little bit more to it. Alright, so here's the vertical displacement equation, all written out. And again, this just comes from your notes. Y initial plus Vyi times t plus gt squared over 2. Alright, spectacular. So we have this, and again, we're just going to plug in the pieces. Y equals Yi. This is the initial vertical displacement, or instead of vertical displacement, this is the same thing as height. So it's the initial height, and I don't see an initial height. which is perfectly fine. That happens a lot. So it's just 0. 0 plus VYI. Now you see why it's so important to keep up with that VYI, because it's going to go in here as well. So I'll look back over here at 6.3, it goes in here. That's why finding that component is so important. It goes in there twice. So I have 6.3t minus 9.8 t squared over 2. And remember I said this negative 9.8 divided by 2 is going to get real familiar, because it is. It's the same thing every time. In fact, you could start, let me just simplify, so 6.3t, and you could just start, instead of writing this gt squared over 2, you could just start writing as minus 4.9t squared, because that is what it's going to be. I mean, if we did a question about a different planet or something, it might be different, but on Earth, it's always going to be negative 9.8, it's always going to be divided by 2, and it's always going to be negative 4.9. Alright, so these are my two equations. So I've done the first part, which is actually the hard part, by the way. The second part is super easy. So the next part, find the velocity at 0.54 seconds and the height at 0.54 seconds. Well, these are functions. They're equations that tell us the velocity or the height. So all I've got to do is plug in 0.54 for t, and I'll get my answer. So in this part, Vy is going to be equal to 6.3 minus 9.8 times 0.54. So I'm putting this on the calculator. I have 6.3 minus 9.8 times 0.54. And I got 1.008. That's kind of unintentional, but we're going to call it 1 exactly. So the velocity at that point is going to be 1. Now that should tell you something, 1 meter per second, of course. That should tell you something. This tells me that this object is still going up at 1 second. Or I mean at 0.54 seconds, it's still moving upwards. It hasn't started falling yet, because it's not negative. If it was falling, it would be a negative velocity. Okay, over here, let's calculate the height at 0.54 seconds. No, sorry, the height at 0.54 seconds. So y is going to be equal to 6.3 times 0.54 minus 4.9 times 0.54 squared. Again, just put in the calculator, 6.3 times 0.54 minus 4.9 times 0.54 squared. And I get 1.97, I'll call it 2. Alright, so you see that was fairly simple. Again, writing the equations is the critical part. You have to write, from here on out, when we talk about things like finding the maximum height or finding the range, the first steps are always going to be to write out the equation, write out the vertical displacement equation, and write out the vertical velocity equation. And of course, to do that, you need to be able to find this vertical component every time. And of course, I just said 0.54 randomly, but it would be kind of interesting. See, I told you this is still going up here. What if I put in 0.75? And you can do this if you want. If you want to do this as an exercise real quick, put in 0.75, pause the video here, and try to get an answer. I'm going to go ahead and put it in and tell you what the answer should be. I just want to see what is the object doing at 0.75. So in terms of velocity first, so I have 6.3 minus 9.8 times 0.75. And sure enough, here I actually have a negative answer, right? So at 0.75, the velocity I got was negative 1.1 meter per second. So see, now it's actually falling. I wonder if it's hit the ground yet. Let's see. Let's figure out what the height is. Okay, so if I plug in, again, I'm just plugging in 0.75, so 6.3 times 0.75 minus 4.9 times 0.75 squared. It still looks like it's up in the air. In fact, it's almost to the exact same point it was. In fact, if I round, I get 2 again. So this is pretty neat. What we just found was, and just totally unintentionally, we found like the 2 points that are equal. Because think about it, this is going to make a parabola, right? So I'm running out of space, but let's do it up here. This is make a parabola. We found a point where it's at 2 meters. So at 0.2 meters, maybe it's like here at 2 meters. So on the way up, it becomes that. And then on the way down, it hits that again. This is going to be interesting because eventually we're going to try to find when does it hit the ground, and that's going to give us 2 answers as well. Of course, you could keep going and eventually you find that it'll hit the ground. You could just estimate. So that's where we're heading. We're going to figure out when does it actually hit the ground, and it's not. The idea is not too hard. The practice is a little bit more difficult, but the idea is pretty simple. But that's where we're heading. So make sure you know how to write these equations, and don't forget to find the component. That's the most important part.